Today we're going to look at problem solving or using two-step equations in the real world. So let's look at these scenarios that can happen, and we're going to write an equation for them and then solve it. Here we have Sarah paid $15.95 to become a member at a gym. She then paid a monthly membership fee. Her total cost for 12 months was $735.95. How much was the monthly fee? So here we see that she paid an initial cost, and then there is a reoccurring monthly fee for 12 months. And we want to know what that fee was. So to write an equation like this, if you think about it and stop for a moment, think about what kind of equation you would write. If you want to pause the video to think about that for a minute, and then we'll show you how it's done here. So in writing this equation, first of all, we have the initial fee. The initial fee was a flat $15.95. In addition to that, so we are going to add, we have 12 months at an unknown rate. So we know we're going to multiply 12 times that unknown rate. And we know that the total was $735.95. So here's how we would set up the equation. Now, in our last lesson, we were looking at how to solve two-step equations. You always locate the variable or what you're looking for. You want to get the x by itself. In order to solve for it, you want the x by itself. So we have to move everything on the left side over to the right side. And we always move what is being added or subtracted first, what's not attached to the variable. This is 12 times x. Whatever's attached to the variable, the multiplication or division, is going to be moved last. So the first thing we want to do is subtract $15.95 from both sides. And when we do that, we find out that we have $720. And we still have 12x on the left-hand side of the equation. X, or the unknown number, is being multiplied by 12. And the opposite of multiplying by 12 is dividing by 12. So here we see that we are going to divide both sides by 12. And when we do that, we find out the monthly fee was $60. Here's another example. Let's read through it, and then I want you to stop and think about how you could set the equation up. Maggie's brother is 3 years younger than twice her age. The sum of their ages is 24. How old is Maggie? You could pause the video if you want to try to come up with a possible equation here. First of all, we're going to start with an equation just for Maggie's brother. So in the first part of the scenario here, it says Maggie's brother is 3 years younger. 3 years younger would mean that we have to subtract 3 from some number. Then what? Twice her age. To get twice her age, you'll be multiplying her age times 2. And so here's where you're going to have your unknown number, your variable. You can use whatever variable you want. But this is an equation right here that just represents Maggie's brother. So let's go back and see what it said. Maggie's brother is 3 years younger, so we're subtracting 3, then twice her age. So we have her age multiplied by 2. Now the second part says the sum of their ages. And we have learned that the word sum is the answer to an addition problem. So now we have to add our original equation to, the first equation was the age of Maggie's brother. Now we want to add that to Maggie's age. So what is that going to look like? So here was the equation we came up with for Maggie's brother. He was 3 years less than twice Maggie's age. So I used the variable n just to represent Maggie there. Then it said the sum of their ages, so I added Maggie's age is, when you read the is, we know that's an equal sign, is 24. Now we have an equation. Now the parentheses are not necessarily necessary, that's good English. But I put them there just to separate this to show that this represented Maggie's brother. But at this point, when you begin to solve, you can just drop the parentheses because you're just looking for like terms. And if you look, we have a 2m and an invisible 1m. If there's no number in front of it, it's an invisible 1. So we have a 2m and a 1m on the left side. We would have combined them together, and that would give us a 3m minus 3. So all we did so far was combine the 2m and 1m. Now we have our two-step equation. We identify where we're looking for the missing number or the variable is. We want to move everything over to the right side away from the variable. We're going to move the negative 3 over first, so we add 3 to both sides. Of course, a negative 3 and a positive 3 is 0, so it goes away. And 24 plus 3 is 27. So we have 3m equals 27. Now m is being multiplied. That means 3m means 3 times m. So m is being multiplied times 3. So now we divide both sides by 3, and you would get 9 years old. Showing what's dividing by 3 there. Okay, let's give you another example. In 2003, the population of Zimbabwe was about 12.6 million, which was 1 million more than 4 times the population in 1950. Write an equation to find the population of Zimbabwe in 1950. Okay, so let's think about writing an equation for this. If you want to pause the video so that you can try one, then we'll do it here. Okay, maybe you've had time to think about what kind of equation you would write to find out what the population of Zimbabwe would be in 1950. Okay, so let's go back. It says that in 2003, the population was about 12.6 million. So I went ahead and wrote out 12.6 million is 12,600,000. I went ahead and wrote that out in standard form, which was, or which is, here's your equal sign, 1 million more than. When you read the phrase more than, you know that you're going to add 1 million more than 4 times, so you know you're going to multiply right here, the population in 1950. So if you look at the equation that I wrote, 12,600,000 is or was 1 million more than 4 times the population in 1950. So as I was reading the equation, I was just translating it into numbers and symbols. Now to solve, we first look for what we're solving for. Here is the variable, the unknown that we're solving for. So we want to get the p on the right side by itself. It is being multiplied by 4, so we're going to move this last. This gets moved last. What's attached to the p gets moved last. So we're going to move the 1 million to the other side first by subtracting 1 million on both sides. When you do that, you get 11,600,000. Is equal to 4p. Because 1 million minus 1 million is 0, so that goes away. We're not finished yet because the p is not by itself yet. P is being multiplied by 4, and what you do to one side of the equation, you must do to both sides. So we're going to divide both sides by the 4. And when you do that, you find out that the population in 1950 was 2,900,000, which can also be written as 2.9 million. Now, your assignment today, I'm going to pull it up here so we can do an example or two together. It's going to be some scenarios where you're going to read through them, you're going to be translating them, writing them into equation, and then solving. So I'm going to show you how you need to show your work on your paper. You can't just write an answer, we have to show some work. Number 1, Jack is thinking of a number 8 more than. When we read the phrase more than, we know that we're going to add. So far it says 8 more than the product means to multiply, the product of 5 and the number. 8 more than the product of 5 and the number So now we're going to multiply 5n, 5 times n, is, and when you read the word is, you know that's an equal sign, is 93. So as I read the scenario, I was just translating it into an equation. 8 more than the product of 5 and the number is 93. Now we have a two-step equation, so we would solve it. First thing I would do is subtract 8 on both sides of the equation. And when I do that, I have 5n is equal to 85. It is not by itself yet. We have to divide both sides by 5. So I'm going to show that I'm dividing both sides by 5. And when I do that, 5 divided by 5 is 1. Well, 1 and the 1 can become invisible, so it goes away. And we have 85 divided by 5, which is 17. So n, the number he was thinking of, was 17. And I write n equals 17, and I circle my final answer. Okay, let's do another example. Let's look at number 7, because number 7 involves a fraction, and for some reason, when we have fractions, sometimes we get a little nervous. Mega Middle School had a Valentine dance. 4/5 of the students, so I'm going to write 4/5 of the students, so 4/5 of the students of. Now when you read the word of in English class, that is a preposition, yes. In math class, when you read the word of, it means to multiply. So 4/5 times the number of students. So I need a variable to represent that. I could use s for students. I'm just going to use x. So 4/5 times the number of students plus 7 teachers. So I just write plus 7. If there were 495 people at the dance, so we know all together there were 495 people, how many students attended the school? So the x right here represented the number of students, so we're just going to solve for the x. First thing we want to do is find the variable. There's the x. It's attached to 4/5, so we're going to remove it last. So we're going to subtract 7 from both sides of the equation first. I'm going to show that I'm subtracting 7 from both sides of the equation. And I would have 4/5 x is equal to 488. Now, when your x is being multiplied by 4/5, which is a fraction, we have to divide by 4/5. When you divide with fractions, if you remember, you actually multiply by the reciprocal. So if we were to multiply this side by the reciprocal of 4/5, which is 5/4, and we were to do all our cross canceling or multiply across, if we multiplied across, that would be 20/20. 20/20 is 1. 1 becomes invisible, so that cancels out. So over on this side, we would also multiply by 5/4, because what you do to one side of the equation, you have to do to the other side. Now, 488 can be put over 1. I can cross cancel the 4 and the 488. Both of those are divisible by 4. So when I divide this one by 4, that would be 122. This would become a 1 now. So I just have 122 times 5, which is 610 students. I'm going to label it, because I know it's asking for the number of students. So my final answer was 610 students, and I circled it. So you can see how you're going to write the equations, you're going to show your work, and you're going to circle your final